In 2024, the fastest car production line in the world set a record of 45 seconds, and it was none other than Tesla with the Model Y. However, Tesla has once again broken its own record. As of now, they have a production line that builds a car in just 33 seconds. It's so fast that the human eye can barely keep up. Let's hear from Lars Moravy, Tesla's Vice President of Engineering.
You know, they're running 2 lines for Model Y now, and they run 13K in 140 hours. They got to be below, like closer to 35 seconds.
Yeah. Do you realize how significant the number 33 seconds per car really is? An automatic espresso machine takes about 30 to 60 seconds to brew a single cup of coffee. That means in the time it takes to make your coffee, a fully assembled car rolls off the production line, and Tesla has a mind-blowing setup like that at Giga Shanghai. At first glance, Tesla's Giga Shanghai looks like just a giant building, but you'd be amazed by what's happening inside. So, how is Elon Musk able to build a car in just 33 seconds? And does that kind of speed come at the cost of quality? Let's dive into this revolutionary production line right now. Welcome to Tesla Car World. When we buy a car, we often focus on its appearance, range, and features. But have you ever wondered where and how these cars are actually made? Currently, Tesla has 5 major factories around the world directly involved in vehicle production. In the US, the Fremont factory produces the full range of Model S, Model X, Model 3, and Model Y vehicles. Gigafactory Texas in Austin is currently manufacturing the Model Y and is set to become the main production hub for the Cybertruck and the upcoming Cybercab robotaxi next year. Meanwhile, Tesla's Giga Nevada is responsible for building the Tesla Semi, a Class 8 electric truck. It's one of the company's most challenging vehicles to manufacture due to its large scale and more complex production requirements. Still, Tesla is confident it can produce 50,000 units per year. In Europe, the Gigafactory Berlin focuses on producing the Model Y for the European market. And finally, in China, there's Gigafactory Shanghai, the star of today's episode, which plays a critical role in manufacturing the Model 3 and Model Y for the Asian market. It boasts the highest production capacity across Tesla's entire global network. We don't think it's an exaggeration to say that the production line here feels like Tesla is building high-tech toys. It's truly so fast that at a glance, it looks like a scene straight out of an AI-generated sci-fi movie, but this is real. Every corner of the factory shows just how quickly they can build a car. At Giga Shanghai, you'll see very few humans working near the line. That's because most of the work is done by robotic arms, giga casting machines, and various automated systems. These machines run entirely on their own, operating non-stop 24 hours a day without rest. And to produce a Model Y in under 35 seconds, do you know what the most critical part of the production line is? It's the manufacturing of the body panels and structural frame of the Model Y. This is the most complex and time-consuming step on the entire assembly line. In the past, Tesla used massive stamping presses, where a sheet of metal, usually aluminum, would be placed between 2 mold halves, then pressed into the desired shape. But that method is now a thing of the past. The new 33-second production line has completely eliminated that approach. Instead, Tesla has introduced a revolutionary machine. This is what many consider the most powerful part of the entire production line, Tesla's Giga Press machine. Even the name sounds like some kind of superpower, and honestly, it kind of is. The Giga Press is like a modern engineering marvel in the auto industry. Elon Musk came up with the idea for this beast of a machine, a giant die-casting press that can mold the entire rear underbody of a Model Y in just 5 seconds, using up to 6,200 tons of pressure. To put that into perspective, imagine an elephant that weighs around 5 tons. Now picture the force of 1,240 elephants. That's what this machine is pushing. We've talked about the Giga Press quite a bit before, so many of you probably already know just how efficient it is. What makes it so revolutionary is that it allows Tesla to cast huge parts of the car's frame, like the rear and front underbody, into single solid pieces. For example, the rear body of the Model Y used to be made of around 70 separate components. With the Giga Press, that's now just 1 or 2 large castings. That means eliminating roughly 370 welds and massively simplifying the assembly process. You see, in a traditional car production line, especially when it comes to the vehicle's frame, things are way more complicated. The body is usually made up of dozens of separate metal parts, stamped out of steel or aluminum, then pieced together using welding, bolts, or industrial adhesives. That method requires hundreds of welds and a bunch of highly precise welding robots. It's time-consuming and energy-intensive. With the Giga Press, since large parts of the car are cast as a single piece, the need for welding those parts together is pretty much eliminated. This casting tech has helped cut the production cost of the Model Y's rear underbody by around 40%. And because so many steps are now combined into this one machine, Elon Musk was able to remove about 300 excess robots from the production line, both for the front and rear of the vehicle. At Giga Shanghai, the Giga Press on the line can cast the Model Y's frame in just 5 seconds. Yeah, you heard that right, 5 seconds from pouring molten aluminum into the mold to pressing it into shape. Then, a robot pulls the mold out, cools it in a 50-degree Celsius water bath, and places it directly onto the assembly line. Using these giant aluminum castings also helps reduce the overall weight of the vehicle, which is super important when you're dealing with the heavy battery packs in EVs. That weight reduction boosts energy efficiency, handling, and overall driving feel. Giga casting the body in 5 seconds compared to a few minutes using traditional stamping and welding is a total time saver. Basically, a machine built to crush time. It's one of the key reasons Tesla can aim for building a car every 33 seconds. Tesla estimates that this one machine alone has helped cut labor costs by about 20%. After the car frame is completed, the next step is assembling these cast components together. This is where a real production line can make your head spin. Inside the factory, you'll see long mechanical arms. These are fully programmed robotic arms. They don't get tired, they don't make mistakes, and they work at such high speeds that humans seem slow in comparison. Whether it's lifting a part, assembling joints, or painting the car, these robots handle everything with unbelievable precision and speed. The Model Y's body frame moves from one robot to the next along the line, with each robot adding another piece to the overall puzzle. Next, the car moves into the paint shop, where the body is coated with a primer, then sanded to create a smooth surface. After that, it goes through a series of painting, dipping, and drying stages, receiving multiple layers of paint and clear coat depending on the final color. White is the easiest color to paint, which is why it's the cheapest. Red is more complex, requiring multiple layers and metallic flakes, making it more expensive. Once the paint is dry and polished, the body is moved on to have interior panels installed, electronic systems connected, and the windows fitted. In parallel with the body assembly process, the car's underbody and drivetrain, which house the vehicle's critical electrical systems, are assembled at high speed through a separate specialized process. We'll explain this as simply as possible. Okay, the process starts with building the structural battery pack. That means the battery is already fully assembled and forms one solid unit. This battery pack is then fixed right in the middle of the Model Y's underbody frame. Next, the front and rear castings, made using the Giga Press, are attached directly to the battery pack at both ends, front and back, forming the entire lower body of the car in just a few simple steps. The electric motors are then immediately installed onto the Giga castings, with one motor placed at the front and another at the rear of the vehicle. These motors are connected through a gearbox and drive shafts, delivering power to all 4 wheels and ensuring full all-wheel drive capability. The suspension system, a key component for a smooth and stable ride, is also mounted onto the castings, followed by the installation of the braking system and wheels. At this stage, the car's underbody starts to take on its final shape and can even move on its own as one large rolling structure, almost like a giant skateboard, incredibly agile and lightweight. Finally, to complete the build, a floor carpet is laid over the structural battery pack, and the interior components are installed into place, forming the inside space of the vehicle. The 4 seats are bolted directly onto the top of the structural battery pack, completing the lower body of the car. This process may sound lengthy, but in reality, it happens in the blink of an eye on an assembly line covered with robotic arms, working with extreme speed and precision. The last crucial step in the production process is mounting the fully assembled body onto the underframe and drivetrain. This step requires high precision, as the 2 sections are firmly connected using a series of bolts around the perimeter of the structural battery and castings. This creates a solid bond that ensures the vehicle's stability and safety. Once the body is attached to the underframe and drivetrain, the Model Y moves on to receive its final finishing touches from the quality control team. This is a vital stage where experts thoroughly inspect the entire vehicle, checking every component to catch and correct any errors or issues. This quality control process ensures that every car delivered to customers meets the highest standards of performance, safety, and overall quality. This is how the production line at Giga Shanghai operates, allowing a fully assembled vehicle to roll off the line every 33 seconds. Now you can start to grasp just how incredible this process is, and the truth is, Tesla wouldn't be where it is today without the Giga factory in Shanghai. With an annual production capacity of over 1 million vehicles, the cost of manufacturing in China is lower than in the US or Europe, thanks to cheaper labor, a strong local supply chain, and support from the Chinese government. This enables Tesla to maximize profits and stay competitive on pricing. It's no coincidence that the Model Y continues to be a top seller in this market, even though customers have many lower-cost alternatives from brands like BYD, Geely, and Xpeng. Despite being built in just 33 seconds, the Model Y's build quality is never in question. It remains one of the best SUVs in its price range. Thanks to the high level of automation at Giga Shanghai, the role of Tesla employees there has shifted to highly sophisticated oversight. Most workers are no longer directly involved in hands-on production. Instead, they monitor the robots, analyze data, and step in only for tasks that require precision and attention to detail. The kind of work machines still can't quite do. However, with the rapid advancement of technology, in the next few years, the role of humans in this factory will mostly shift to supervision, while the majority of the work will be handled by robots and AI. In particular, Tesla's humanoid robot, Optimus, is expected to be trialed at Tesla factories. The truth is, many jobs currently done by Tesla employees will likely be replaced by this robot, simply because it's incredibly smart. What's even more surprising is that this factory runs 24 hours a day, 7 days a week. There are no breaks, no traditional shifts, no bells signaling the end of work hours. Everything inside the factory is controlled by a network of sensors, software, and AI algorithms. When an issue arises with any machine, the system automatically detects it, sends out an alert, and if needed, activates a backup machine instantly. This is why Tesla Giga Shanghai is often referred to as a self-healing factory. Every part of the factory is connected to data, constantly tracking and recording each movement and the condition of every component, ensuring production quality stays at the highest level and any faults are detected in real time. Another standout feature of the factory is the presence of automated guided vehicles, small, agile robots that transport goods throughout the facility. These vehicles don't need drivers. They can autonomously navigate paths, stop, turn, and manage internal traffic intelligently, helping optimize operations without human intervention. China is the largest EV market in the world. Giga Shanghai allows Tesla to manufacture cars locally, avoiding high import taxes while meeting the growing demand from Chinese consumers for models like the Model 3 and Model Y. But Elon Musk's decision to build Giga Shanghai goes beyond just serving the local market. It was also intended to turn the factory into Tesla's export hub for Asian, European, and other global markets. This helps Tesla reduce reliance on its US factories and optimize logistics. Giga Shanghai plays a strategic role in producing Tesla's next-generation EVs, particularly the upcoming affordable model expected to cost around $25,000 and launch by the end of 2025. According to Lars Moravy, Tesla's VP of Engineering, this new vehicle will be produced on the same line as the Model Y, leveraging existing infrastructure to reduce costs and speed up development. Thanks to its compact design and an 80% reduction in the number of parts compared to the Model Y, this new model will not only be cheaper, but also achieve an incredible production speed, possibly as fast as one car every 20 seconds, far surpassing the current 33-second record held by the Model Y. Additionally, the new vehicle is confirmed to use lithium iron phosphate batteries supplied by CATL, the world's largest battery manufacturer. Producing this affordable EV at Giga Shanghai means Tesla won't have to pay import tariffs on batteries sourced from China. Markets like the US impose a 25% tariff on lithium-ion batteries and a 100% tariff on EVs imported from China, while Europe also has similar trade barriers. By integrating LFP battery production and vehicle assembly at Giga Shanghai, Tesla eliminates these tariff costs, helping keep the price of the Model 2 highly competitive. China, the world's largest EV market, is the ideal place for Tesla to launch this affordable vehicle. As mentioned earlier, Giga Shanghai offers a major cost advantage thanks to a strong local supply chain and government incentives. The factory also serves as a key export hub, allowing Tesla to deliver this low-cost model to global markets and compete with rivals like BYD. China accounts for over 50% of global EV sales, with strong and growing demand. Launching new models here allows Tesla to tap directly into a massive customer base and make a big impact in the world's most critical EV market. In our view, producing the $25,000 model at Giga Shanghai not only strengthens Tesla's position in the mass-market EV segment, but also showcases its technological edge, with highly automated production lines and rapid manufacturing capabilities. This is a crucial step in Tesla's mission to accelerate the global adoption of electric vehicles, especially amid fierce competition in China. In your opinion, what are the biggest advantages of Tesla producing a Model Y every 33 seconds? Do you think other car manufacturers can match Tesla's 33-second production speed at Giga Shanghai? Tesla's Q2 earnings call just wrapped up, and once again, all eyes were on Optimus. Excitement was clearly in the air after Elon Musk confirmed several key updates about the upcoming Tesla Bot version 3, most notably, a major design overhaul compared to the current 2.5 version we've seen so far. Now we know design isn't the most important aspect of a humanoid robot, but let's be honest, it still matters. Nobody wants to buy a robot that looks like some creepy Terminator, right? But that's not all. Musk emphasized that Tesla Bot 3 will feature significantly more degrees of freedom. If you know anything about humanoid robotics, you'll know how critical that is. It directly impacts how human-like the robot can be in its movements and functionality. Okay, version 3 of Optimus is expected to be capable of performing up to 3,000 useful tasks, and according to Elon, once again, this will be Tesla's most mass-produced and biggest product yet. So the big question, how much will this version cost? And what's Tesla's roadmap for commercialization? Let's dive into the details. Welcome to Tesla Car World. Just a few days ago, Tesla Diner officially opened, and what better way to promote it than by bringing Optimus in to serve popcorn to customers? A lot of people were amused and even excited by it. Most had the same thought, what if I had a Tesla bot at home to serve? Well, that idea might not be too far off since Tesla bots are set to go on sale next year, though at first, supply will be limited. At the start of Tesla's Q2 earnings call, Elon Musk jumped right into talking about Optimus. Unfortunately, the audio quality during the call was pretty bad, so we won't be using clips in today's video. Instead, we'll just recap what Elon said. He mentioned that we're evolving to Optimus design and getting Optimus to the point where it is a phenomenal design. Optimus is currently at version 2.5. Optimus 3 is an exquisite design in my opinion, and will be an incred. As I've said many times before, I predict it will be the biggest product ever. Musk called Optimus 3 a phenomenal design and predicted it could become the biggest product ever. Of course, this isn't the first time Musk has made these claims because on earlier posts on X, he wrote, Optimus 3 will have agility roughly equal to an agile human. But this time, he emphasized that every part of Optimus was designed based on fundamental physics principles. With version 3, the robot has been almost completely redesigned compared to version 2.5. According to leaks, Optimus 3 will feature a face with an integrated digital display and Grok voice support, something Musk had previously confirmed. The display will show its current status and any information the user wants to look up. In simple terms, it'll be like having a computer screen right on the Tesla bot's face. Meanwhile, when it comes to the body, Tesla is reportedly aiming for a lighter design in an effort to improve Optimus's walking speed. It still hasn't hit the company's target of 5 miles per hour. It's unclear exactly how the engineering team plans to update the body. It could mean switching to lighter materials or redesigning the still rough joint structure. But according to Elon Musk, the new design is going to be something extraordinary, and it's expected to be revealed later this year. Elon stated, with Optimus 3, which is really the right design, it's like it doesn't have at this point. There's no significant flaws with the Optimus 3 design, but we are going to retool a bunch of things. So it'll probably be prototypes of Optimus 3 into this year, and then scale production next year. If our prediction is right, Elon Musk will likely unveil Tesla Bot version 3 at the biggest event this November, Tesla Shareholder Meeting 2025. That would make perfect sense, especially since Musk has hinted at the idea of being joined on stage by a few Optimus robots during the annual shareholder meeting. They might do something fun like dance or bring a mic to the stage. One thing we're confident about, Optimus version 3 is coming by the end of this year, marking exactly 2 years since Gen 2 was introduced in late 2023. The redesign of Optimus 3 also plays a key role in expanding the number of useful tasks it can perform. A better design allows Tesla to add more degrees of freedom, making the robot more capable and versatile. In fact, Elon Musk addressed a popular question from investors. What specific factory tasks is Optimus currently performing? And what's the expected timeline for scaling production to allow external sales? Also, how does Tesla see Optimus contributing to revenue over the next 2 to 3 years? In response to this question, Musk confidently said, "The Optimus 3 design, as I mentioned earlier, I think finally the right design. There'll be further optimizations, but there are no fundamental changes to that are needed for the Optimus 3 design. It has all the degrees of freedom that you really want or need. So we'll have prototypes of that in 3 months, and we'll certainly start production in the beginning of next year." Degrees of freedom refer to the number of independent ways a robot can move. For example, a robotic arm might rotate, bend, or move up and down. Each of those movements counts as 1 degree of freedom. With a more optimized design, Tesla can integrate additional joints, motors, and advanced sensors, making Optimus more agile and capable of handling complex tasks. Right now, Optimus version 2.5 can handle around 1,500 basic tasks. But with version 3, that number could easily double because the bot will be able to perform a wider variety of actions. For instance, while Optimus 2.5 might be able to hold an egg without breaking it, Optimus 3 could take it a step further. Crack the egg, cook it, and serve up a fried egg. You get the idea. The more degrees of freedom it has, the more precise and versatile it becomes. Hitting 3,000 tasks wouldn't be surprising at all. However, alongside the exciting news about the new version, Elon Musk was also candid in admitting that developing Tesla Bot version 3 is an extremely difficult problem. He pointed out that none of the components are off the shelf, because frankly, nothing out there is truly suitable for such an advanced robot. From the motors and gearboxes to power electronics and sensors, every single part is custom designed by Tesla. Musk stated, "It's a very hard problem to solve. You have to design every part of it from physics first principles. There's nothing that's off the shelf that actually works. So you're going to design every motor, gearbox, power electronics, control electronics, sensors, the mechanical elements. We also got to train Optimus to use its limbs and its sensors with a neural net." Interestingly, Musk once again drew a parallel between Optimus and Tesla's EVs, saying both are essentially robots, just in different forms. He emphasized that Tesla is applying the same AI optimization techniques from its self-driving cars to Optimus. That includes training the robot's limbs and sensors using neural networks. During the meeting, Musk confidently declared that Tesla is the best in the world at real-world AI. He explained that the company's experience with full self-driving gives Optimus a major advantage when it comes to operating smoothly in real environments. At the very least, it'll be able to avoid obstacles effectively and build its own map to navigate just about any setting. Musk also revealed that Tesla is working to ramp up Optimus production as quickly as possible. In a bold prediction, he said Tesla could be building up to 100,000 Optimus robots per month by the year 2030, an estimate that honestly left us stunned. He emphasized that he would be very shocked if Tesla doesn't hit this target within 5 years. However, Musk also openly admitted that the first 1 to 2 years will be tough, as issues like supply chain disruptions or internal errors could arise when developing a groundbreaking product like Optimus. The Tesla CEO also acknowledged that adding new features to Optimus 3 might slow growth due to potential supply chain interruptions or internal mistakes. We see this as a realistic warning, since Tesla often faces challenges when scaling up production. "We're not always on time, but we get it done," Musk said, referencing the company's tendency to make the impossible feel late. He also reiterated the idea that Tesla can be the most valuable company in the world if it executes very well. Elon Musk has previously emphasized that the improved design of Optimus 3 is optimized for mass production. However, we need to clarify that mass production doesn't necessarily mean Optimus 3 will be cheap. Our most optimistic estimate puts the price at $50,000. Compared to the $20,000 price Elon Musk has mentioned multiple times, that's definitely not a low price. But let's break down why, even at $50,000, Optimus version 3 would still be a worthwhile investment. First off, Optimus can handle thousands of tasks, from cleaning and caring for the elderly or kids to assisting in manufacturing. It can save a lot on labor costs. For example, in the US, a worker earns about $35,000 a year, while Optimus can work continuously way more hours than a person can in a year. It doesn't need to sleep, only about 20 minutes to fully charge, and can work non-stop for 8 hours. For households, instead of paying $2,400 to $6,000 a year for a housekeeper, Optimus can take care of chores like cleaning, laundry, pet care, and even help with kids' learning, so you'd recoup your investment pretty quickly. Elon Musk stated Tesla bot will be everywhere among the 8 billion people worldwide, and the $20,000 price might be for Optimus Gen 2. Do you think Optimus can really pay for itself like Musk claims? Basically, that's what Elon Musk said about Optimus at the earnings call. There's still a lot that needs to be done and sped up moving forward. Tesla Optimus isn't your typical product, and Optimus 3 demands even more advanced engineering. So, we're really looking forward to seeing what the prototype of this new version will be like. Now, let's get back to the role of the Tesla bot at the supercharger diner. Musk said Optimus will be getting a promotion in 2026, and it will be a food runner, bringing your order straight to your car, eliminating the need to go inside yourself. That means right now we only see it serving popcorn, but next year it'll be a lot busier. And of course, this increased activity is definitely something we'll be excited about. Moving on to a few other important announcements from the earnings call, Musk reaffirmed Tesla's commitment to robotaxi technology. The ride-hailing service is expected to expand within the geo-fenced areas of Austin over the next 2 weeks. Tesla is also preparing to seek regulatory approvals in regions like the Bay Area, Nevada, Arizona, and Florida. Musk expects that by the end of 2025, the robotaxi network could cover half of the U.S., depending on the approvals. During the meeting, Elon Musk also reiterated that Tesla's tech edge gives the company significant long-term profitability. However, he acknowledged that the company's recent downturn will likely continue or even worsen temporarily until the new autonomous transport projects start generating revenue. One hot topic right now is the deadline after the federal $7,500 tax credit for EV purchases expires on September 30th. The Model Y is currently one of Tesla's most affordable car, with the RWD version starting at around $45,000. This has been a key factor in making the Model Y the best-selling car in several countries like Turkey, Switzerland, Austria, and a few others. Its popularity highlights the huge potential of the Model Y, especially since it's basically leading the market and could become the top-selling car in 2025. The increase in Model Y production this quarter is a big step forward, showing Tesla's efforts to meet growing consumer demand. On top of that, Tesla has confirmed plans to develop a new, more affordable model expected to launch in 2025, with initial production already kicking off in the first half of the year. This is exciting news, especially as Tesla is committed to offering a lower-cost EV option that fits a wider range of customers. However, this plan has faced some hurdles. The launch of the cheaper model has been delayed due to cuts in EV tax credits and the company's focus on retooling factories to produce the new car. Tesla expects to ramp up production next quarter, though that's slower than originally planned. A key highlight of this affordable model is its ability to integrate full self-driving, an advanced feature that adds a lot of value. Initial production will start in North America, and Tesla is working hard to stay on schedule. If all goes well, the car could hit the market by Q4 this year, promising to open a new chapter for affordable electric vehicles. With a lower price than the Model Y and full self-driving technology included, this could be a game-changer for Tesla to expand its market share, especially in price-sensitive areas. Additionally, Tesla plans to continue pursuing a new production method for the Cybercab in 2026, possibly using a revolutionary assembly line called the unbox process. Unlike expectations around superior handling or impressive cornering, the Cybercab is designed to be a safe, affordable taxi. With a lighter, much more efficient design, it focuses on smooth, easy rides, perfect for daily passenger pickups and drop-offs. Musk also emphasized that the cost per mile for the Cybercab will be very low, much cheaper than Tesla's current fleet. Tesla is continuing to prepare for a wider rollout of FSD supervised in China, currently awaiting regulatory approval. Although FSD is already available there, it's currently limited to Hardware 4, showing that Tesla is optimizing the tech to meet local standards. At the same time, Tesla is getting ready to launch FSD supervised in Europe, but still needs regulatory approval. Once approved, sales in Europe are expected to increase significantly. This quarter, Tesla successfully completed an automated delivery of a Model Y to a customer within 30 minutes, including highway driving, a major milestone after a lot of effort and time, marking the first successful autonomous delivery. This is just the beginning of the next phase, with plans to roll out self-deliveries in the Bay Area and Austin by the end of the year. Robotaxis have already logged 7,000 miles with a limited number of vehicles, and expansion of both the service areas and fleet will happen soon, which is expected to have a big financial impact for Tesla by the end of 2026. As a conclusion for today's episode, Tesla Optimus could be a revolutionary product not just in technology, but in how we live and work. By automating repetitive and dangerous tasks, Optimus will help reduce reliance on manual labor while boosting productivity and cutting costs. Powered by advanced AI, Optimus could take on a wide range of roles, from elder care to industrial support, completely changing how we interact with our jobs and daily lives. That said, the rise of Tesla Optimus could also bring significant challenges for employment. Many current jobs, especially in manufacturing, healthcare, and warehouse operations, might be replaced by robots. This raises concerns about job losses for workers who can't easily adapt to new technology. However, Optimus's arrival also opens new opportunities. It will create demand for jobs in robot research, development, and maintenance, as well as new roles in creative fields where humans can fully leverage their thinking and emotional skills. So the future of Tesla Optimus isn't just about technological change, it's also about a transformation in the labor market. If managed and regulated properly, Optimus could create a future full of new job opportunities. With the upcoming upgrade to Optimus 3, we see this as a bold move, showing that Tesla isn't just aiming to build a robot, but a true technological masterpiece. We know that most of today's new battery technologies still haven't earned the public's full trust, mainly because many of them are still in the research or testing phase, and the big promises of breakthrough performance often come without any real-world proof. However, in the landscape, BYD, one of the world's leading battery and EV technology companies, and a top rival to Elon Musk's Tesla, is making a very noticeable difference. As we all know, BYD already has the Blade battery, a lithium iron phosphate battery that's well known for its safety and durability. In fact, Tesla uses this type of battery for its Model Y in Europe. But now, BYD is taking things even further by developing a battery that the entire world is chasing, a solid-state battery. They've already successfully built a prototype on a pilot production line, and they plan to begin large-scale installation of these batteries in their vehicles soon. This new battery boasts twice the energy density of current batteries, allowing for a driving range of up to 900 miles on a single 12-minute charge. If BYD sticks to its roadmap and rolls this out as planned, Elon Musk might be the first to feel the heat because clearly this battery could be a total game-changer for the global EV market within this decade. We're about to dive into the details and everything that's been revealed so far about this new battery technology. Every time a new battery is mentioned, most people probably just laugh it off thinking, oh great, another gimmick. The belief is that these kinds of batteries will never make it to mass production, let alone become common in EVs. Honestly, we used to think the same. And that reaction makes sense. Lithium-ion batteries have become the gold standard for EVs thanks to their stable energy density, and the fact that their costs have dropped dramatically, from around $1,000 per kilowatt hour in 2010 to about $130 per kilowatt hour in 2024. However, if you look a little deeper, not just us but many experts agree, lithium-ion batteries are one of the biggest reasons EV performance has plateaued. Despite being used widely for decades, they've held back innovation and limited public confidence in EVs. But why is that lithium-ion batteries have always faced several challenges, including the risk of fire and explosion due to thermal runaway when damaged or overheated? On top of that, technological innovation has been relatively slow. Energy density has only improved by about 5 to 10% per decade. There are also growing environmental concerns around the mining of raw materials like nickel and cobalt. Because of these issues, many alternative battery technologies have been explored, and among them, solid-state batteries have consistently stood out as the brightest star. Solid-state batteries offer major improvements, with energy density that's 2 to even 3 times higher than today's LFP batteries. Their durability and safety make them even more promising, as they are almost non-flammable. This is why the EV industry often refers to them as the holy grail of EV batteries. To put it simply, every battery cell consists of 4 key components: the anode, cathode, electrolyte, and separator. As the name suggests, a solid-state battery uses solid materials for all these parts, most importantly, the electrolyte. What truly sets solid-state batteries apart is this solid electrolyte layer between the anode and cathode, whereas traditional lithium-ion batteries use a liquid electrolyte in the same position. This is exactly what gives solid-state batteries their advantage. They can store more energy and deliver higher power, while also being much safer than lithium-ion batteries. Liquid electrolytes in traditional batteries are flammable, prone to leakage when the battery is cracked, and can cause thermal runaway to spread quickly from one cell to another. Most current manufacturers use ceramics or polymers as solid electrolytes. Now, back to BYD's solid-state battery. The company is currently testing it in their BYD Seal sedan. According to Chinese media, BYD's solid-state battery has impressed with its charging performance. The Seal EV equipped with this battery can reportedly achieve a driving range of 932 miles, with just a 12 minutes charge from 0 to 80%. Even crazier, a full charge could take the vehicle up to 1,165 miles. Think about that. That's nearly 4 times the range of many EVs on the market today. It's enough to drive from New York to Chicago. And while these figures are based on China's CLTC standard, they're still incredibly impressive. BYD confirmed that their solid-state battery delivers an energy density of 400 watt-hours per kilogram, almost double that of typical lithium-ion batteries, which average around 210 watt-hours per kilogram, and significantly more than their current blade battery, which offers only about 160 to 165 watt-hours per kilogram. To achieve this range, BYD has upgraded both the electrode materials and the solid electrolyte. Reports indicate that the company uses an ultra-thin composite oxide solid electrolyte and high-capacity anode and cathode materials to accelerate charging and discharging. These improvements also enhance ion and electron conductivity, increasing both energy density and overall battery efficiency. Just imagine this. If you buy a current BYD Seal equipped with an 80 kilowatt-hour blade battery, you'll get around 373 miles of range. With the new solid-state battery, that same size pack could give you up to 870 miles, but you might not even need that much capacity. A smaller 60 kilowatt-hour battery could still deliver up to 621 miles. Absolutely insane. The higher energy density of solid-state batteries means you can store more energy without adding weight, a critically important factor for electric vehicles. Of course, 400 watt-hours per kilogram isn't a groundbreaking number compared to some other solid-state cells. Companies like CATL, Amprius Technologies, and QuantumScape have already developed batteries that exceed 500 watt-hours per kilogram. But BYD is taking a more conservative approach with its first-generation cells. They're avoiding overreaching too early, opting instead for a more achievable target that allows for faster mass production. They can always improve and scale up from there. With Tesla's supercharger stations, you can charge a 2170 battery to 80% in about 30 to 40 minutes. For the newer 4680 battery, charging from 10% to 80% takes around 25 minutes. However, BYD has stated that its solid-state battery will only need 12 minutes of charging to achieve a 900 miles range, an undeniable breakthrough. But this feat isn't just about the battery itself. It also requires integration with an ultra-fast charging system. Earlier this year, BYD shook the industry by announcing a new vehicle architecture that supports 1,000 kilowatt charging. At its core, solid-state batteries inherently charge faster than traditional lithium-ion batteries because they use a solid electrolyte instead of a liquid or gel. Solid electrolytes, typically made from oxide or sulfide materials, allow for faster ion conduction, lower internal resistance, and enable higher current flow during charging. Additionally, solid-state batteries often utilize high-power electrode materials, such as lithium metal anodes, which enhance electron transfer efficiency. This structure is also more stable under high charging currents, reducing the risks of overheating or dendrite formation, both major limitations for the fast-charging capabilities of lithium-ion batteries. Thanks to these advancements, solid-state batteries can achieve ultra-fast charging speeds like BYD's claimed 12 minutes benchmark, while still maintaining safety and efficiency. In China, there are already some vehicles capable of charging at that speed, although 1 megawatt charging stations are still very limited worldwide. However, BYD is planning to build more in Europe and China, and we've heard they're also scouting locations in Australia, something that will definitely take a lot of time and money, but is also quite exciting. BYD's solid-state batteries also offer significantly improved safety compared to traditional lithium-ion batteries that use liquid electrolytes. As we mentioned earlier, the safety of solid-state batteries comes from replacing the flammable liquid electrolyte with a solid one, such as sulfides or oxides, which reduces the risk of fire and thermal runaway. Solid electrolytes have higher thermal stability, with higher melting points, making them much less likely to catch fire even when the battery is severely damaged, such as in traffic collisions. Compared to NMC lithium-ion batteries, BYD's solid-state batteries reduce the fire risk due to the absence of flammable liquids, a known issue in rare but serious battery fires that can sometimes require thousands of gallons of water to extinguish. BYD's testing, including durability checks with 20 amp-hour and 60 amp-hour cells in 2024, has shown that their solid-state batteries can withstand extreme conditions like punctures, crushing, or overloading without producing smoke or fire. This is similar to the impressive results of the Blade battery LFP in the nail penetration test, where surface temperatures only reached 30 to 60 degrees Celsius. However, BYD's solid-state batteries are not entirely immune to risk. Studies have shown that in the event of severe accidents involving crushing or puncturing, solid-state batteries can still catch fire, though the risk is significantly lower compared to lithium-ion batteries. Additionally, BYD uses a composite structure with glassy sulfides embedded in a glass oxide matrix, which enhances ionic conductivity and mechanical strength. However, ensuring interfacial stability between the electrodes and the electrolyte is critical to preventing the formation of dendrites, metallic lithium structures that can cause short circuits. While this risk is lower than in lithium-ion batteries, it still presents a technical challenge. Despite BYD's strong advantages in supply chain integration and large-scale Blade LFP battery manufacturing experience, the company is facing major challenges in cost and production lines as it enters the solid-state battery space. The first challenge comes from material costs. Unlike Blade LFP batteries, which use common and inexpensive materials, solid-state batteries require specialized components such as solid electrolytes made from sulfides, oxides, or polymers, lithium metal or silicon carbon anodes, and materials of extremely high purity. These materials are expensive, difficult to handle, and extremely sensitive to moisture, requiring strict manufacturing conditions, all of which drive the production cost significantly higher than traditional batteries. Current estimates suggest that solid-state batteries could cost 2 to 4 times more than conventional lithium-ion batteries, making it nearly impossible in the short term to integrate them into the mid-range and mass-market vehicles that BYD currently leads in. On top of that, BYD can't simply repurpose its existing production lines. Manufacturing solid-state batteries requires a completely dry, moisture-free environment, with precision processes that are almost on par with those in the semiconductor industry. Key steps like pressing the solid electrolyte layers, coating the anode and cathode, and detecting microscopic defects are entirely different from the slurry coating and roll pressing techniques used in LFP battery production. This means BYD must invest in building entirely new production lines, from machinery and clean rooms to quality control systems, an extremely costly investment that could take years to optimize. Moreover, current solid-state battery manufacturing still suffers from low yield rates and limited efficiency. Many reports indicate that only about 60 to 70% of produced cells meet quality standards, compared to 95 to 98% for LFP batteries. This drives production costs even higher, especially during the early phases when scaling up remains a challenge. Tesla was surpassed by BYD in revenue for the first time last year. At this point, Elon Musk hasn't made clear moves toward adopting or investing in solid-state battery technology, and we believe the main reason for this delay is cost. Tesla has already invested heavily in optimizing the production of its 4,680 battery cells, so committing resources to an even more premium and technically demanding battery like solid-state could face significant hurdles. However, if the cost drops, there's a strong chance Tesla would consider adopting the technology. We're not saying Elon Musk will definitely bring solid-state batteries to Tesla, but it's also not something we can rule out, especially considering Tesla already uses BYD's blade batteries in the Model Y produced at Giga Berlin. BYD will be testing its new battery until 2027, when the company plans to begin small-scale mass production of the new cells. This phase will allow BYD to better understand the battery's real-world performance and limitations. The company has completed lab testing and is confident in the safety and performance of its solid-state battery cells. If no critical weaknesses are found during testing, BYD plans to initiate limited mass production in 2027. Full-scale mass production is scheduled for 2028, although electric vehicles equipped with SSBs will be more expensive than those powered by liquid electrolyte batteries. Currently, the BYD Seal is priced between $24,500 and $33,400. Analysts expect the switch to solid-state batteries will increase prices by around $3,500. However, BYD estimates that SSBs will reach cost parity with liquid electrolyte batteries by 2030. Aside from BYD, Samsung is the second company we have strong confidence in when it comes to the future of this technology and their seriousness about it. Quiet but deliberate, what Samsung is doing makes it clear they're not just joining the race, they're aiming to lead it. At Battery Day 2024 in South Korea, Samsung officially announced that its pilot production line for solid-state batteries is now operational, and the first samples have already been sent to major EV manufacturers for real-world testing. The company aims to commercialize solid-state batteries by 2027. However, what's capturing the attention of the tech world and the automotive industry isn't just the production timeline. It's the numbers this battery technology delivers. Samsung claims its solid-state battery has an energy density of up to 500 watt-hours per kilogram, double that of current lithium-ion batteries and higher than BYD's solid-state cells. According to Samsung, this allows EVs to achieve a driving range of up to 621 miles on a single charge, far beyond any electric vehicle currently on the market. The charging time is equally impressive, just 9 minutes to reach 80%. This is no longer a vague promise, but a set of concrete specifications tied to a working prototype that has already undergone testing. Samsung's core technology lies in its use of a proprietary solid electrolyte, combined with a high-energy lithium-manganese cathode and a composite silicon-carbon anode. Notably, the company has completely eliminated the traditional metal anode, saving space and significantly increasing energy capacity. This approach results in a battery that is lighter, safer, and more efficient. In terms of durability, Samsung is targeting a battery lifespan of up to 20 years. Additionally, by eliminating the use of liquid electrolytes, the risk of fire or explosion, a key weakness in today's battery technology, is effectively removed. That said, Samsung is candid about the current cost challenges. Materials like ceramics and glass used in the solid electrolyte require extremely precise and controlled manufacturing conditions. As a result, in the early stages, Samsung's solid-state batteries will be used in premium vehicle models. But, like any emerging technology, costs are expected to come down over time as production scales up and processes are optimized. Today, major leaps in energy storage are reshaping how we think about EVs. Solid-state batteries clearly offer the promise of electric vehicles that can travel 600, 800, or even 1,000 miles on a single charge, recharge in just a few minutes, and last up to 20 years. Among the key players, BYD is taking a practical approach to solid-state batteries, focusing on greater safety, stability, and a path towards scaled production within this decade. With mass production plans and a promise of cost parity by 2030, BYD's solid-state battery could be the next big leap forward. But will it truly be a game-changer or just another overhyped innovation? What do you think about BYD's solid-state battery? Drop your comment below. Thanks for watching.